Hello, this is Mr. Henry, and welcome to lesson 2.1. This unit is on scientific notation. I believe there are 3 lessons in it. So this first lesson is just trying to understand what scientific notation is, how to write it, how to convert it from one type to another. Pretty basic. The next few lessons get into working with scientific notation, adding, subtracting, multiplying, dividing, doing problem solving with it. That sort of thing. Okay, so the essential question says here, how do I use scientific notation to represent very big and very small numbers? Did you know that the weight of the Earth is approximately this many pounds? Now, this is written in scientific notation. In case you didn't know what scientific notation looked like, there it is. So if you were a rocket scientist and you have to account for the mass of the Earth in all your calculations, it would be much easier to use that in scientific notation, 1.317 times 10 to the 25th pounds, instead of writing this. This is that same number in standard form. Standard form is the way we normally write the numbers, where they're with all the commas and you write out every number. So you can see in standard form that is a huge number. But in scientific notation, it is a lot smaller. Okay? That is kind of one of the main reasons why people would use scientific notation. So scientific notation, vocab word, it is a way of writing very big or very small numbers. And it always looks like this, where the number out front is always between 1 and 10. It has to be less than 10, but it could actually be 1, 1.01, 1.02, the whole way up to 9.999999999. You actually cannot get 10. And this n out here has to be an integer. Integers being like 0, -2, 8, 17, no fractions, no decimals. Okay, so I have a couple examples of 2 numbers in scientific notation here for you to look at. You'll notice that this is always a times by 10. That's kind of what scientific notation looks like. If that's something other than 10, then it's not scientific notation. Now, standard form. Standard form is kind of like the normal way we write numbers, using commas and decimals, and you write out all of the digits. So these 2 examples, that is both in standard form. Right? You can pause the video if you need the vocab a little bit longer. I am moving on. Example 1 here says we are writing numbers in scientific notation. So directions say, write the following numbers in scientific notation. Awesome. This is actually pretty easy to do. So, the form for scientific notation is you have a number out front times by 10, there you go, times by 10 to some power. Now, all you got to do is figure out what is this decimal that goes out front and what is this integer up top. It's always going to be times by 10. Always. So, how do you know what the decimal looks like out front? It's actually very easy. You want the number out front here to basically be this number, but with the decimal between the first 2 digits. Right there. So, between the 8 and the 6 is where we want this. So now, if I would write this down, this becomes 8.67. And I know I did this right because this number out front, as we said, always needs to be between 1 and 10. This is 8.67. That is between 1 and 10. That is correct. You will only ever have one number in front of the decimal. Ever. Okay? So now we have this number out front. And the last thing we got to figure out is what is this power here that would turn this number into this. And the answer is you have to count the number of places you move the decimal. You're not counting zeros. If you think this is a 5, you are wrong. It is not 5. So in this original number in standard form, the decimal started way back here because this was a whole number. And when you have a whole number, the decimal starts in the back. So the decimal starts here, and we want it to go way over here. How many places would we move the decimal? Well, we count them. We'd move the decimal 1, 2, 3, 4, 5, 6, 7 places. So this exponent out here is a 7. Now you could actually probably, for some of these, check it on your calculator. If you take in 8.67 times by 10 caret 7, it should give us the exact same number back. Now, our calculator doesn't show with commas in there, but there should be 5 zeros. 1, 2, 3, 4, 5 zeros. So we got the exact same number. Now, this won't work for all numbers in scientific notation because some numbers in scientific notation, the whole point of it is you can do really, really big numbers. If I go back to this screen here, I can't type in this number in scientific notation in my calculator. Well, I lied. I can. 1.317 times by 10 caret 25. The problem is the calculator can't write that number out. It is way too big for the calculator to put all those zeros, all those numbers on the calculator. So it's just going to give me the answer back in scientific notation. Okay, so you can't always just use the calculator to do the work for you or to check your work. But it's okay here for a couple of these problems. All right, so letter B. We want to write in scientific notation. So I know to make this number between 1 and 10, I would like the decimal to go right here. To make this number 4.924 times by 10 to what power? How many places would you move the decimal from where it starts to where you want it to go? And hopefully you're saying 2 because the decimal starts right here. Look at them. That's where the decimal was in the original problem. If I move this guy out of the way, that's the original number. It started here, and we wanted it to go 1, 2 places over. So this is to the second power. So I would like you to try these 2 problems. Please go ahead and copy them down. Pause the video. Try them on your own. When you are ready to continue, hit play, and we'll go through them together. All right, so letter C here. The decimal out front is going to be 1. Or if you said 1.0, that's okay too, but you really don't need the 1.0. So it's 1 times by 10 to what power? Well, how many places would you move the decimal from here to here? You'd move the decimal 1, 2, 3 places. Letter D. Where would you put a decimal in here? Between which 2 digits would you put the decimal to make this number between 1 and 10? So there's only one number in front of the decimal. The answer is right there. It always goes between the first 2 numbers. Always. So this becomes then 6.393. I don't need the 0. Zeros at the end of after a decimal are unneeded. So 6.393 times by 10 to what power? Well, how many places would we move the decimal from where it started? It started here because this is a whole number. If you don't see a decimal, it's always at the end. And you wanted it to go up front, so you moved it 1, 2, 3, 4 places. So our number is 6.393 times 10 to the 4th power. That is 63,930 in scientific notation. Okay, so writing in scientific notation is fairly easy. What if the numbers are very, very small? Because scientific notation can do that too. Part of our definitions, we said it can write very big or very small numbers. Well, these numbers are very small. Look at that, 0.000032. Very small. That is 32 tenths, hundreds, thousands, 10,000s, 100,000s, million. 32 millionths. Okay? That is a very tiny number. Well, scientific notation is going to work the same way. So first off, the decimal is going to go between the first two digits. Here. Between the 3 and the 2. That's where we want him to go. So this number becomes 3.2 times by 10 to some power. And we need to count how many places we would move the decimal. So the decimal started here, we can see it, and it went 1, 2, 3, 4, 5 places. Now, there's a slight problem. If you would type this into your calculator, 3.2 times by 10 to the 5th power, it does not give us what we had. It does not give us what we started with. The problem is because in this problem, we moved the decimal the other way. We moved to the right. In the last couple of examples, we were going from a bigger number and changing it smaller. Here, we're going from a small number and kind of changing it to a bigger, making it 3.2. So what we actually need to do is we need to change our exponent to make it negative. We went -5 places. Now, if I type that in the calculator, 3.2 times by 10 caret -5, look at that. Now we got the same decimal. Okay? So the way that I remember this is if your number is a big number, you get a big positive exponent. If the number in standard form is a small number, then you get a small negative exponent. Okay, so big number, big exponent, small number, small exponent. That's how I kind of remember to keep them separate, make sure I understand that the small numbers get the negatives. Okay? Letter F. Same dealio. My decimal, I would like to be right here, between the first two digits. So this is going to be 1.62 times by 10 to a power. Well, what power is it? Since this is a small number, I know it's going to be a negative. -1, -2, -3, -4, -5. 1.62 times 10 to the -5th power. Okay? I would like you to try these two, please. Go ahead and copy them down, pause the video, try them on your own. When you're ready to continue, hit play, and we will go through them together. Alright, so this one should be 7.3, because we want the decimal between the first two digits, 7.3 times by 10 to what power? Well, this is a small number. It's less than 1. So it's going to be a negative exponent. And how many places would you move that decimal? Well, you only have to move in one place. So it's 7.3 times by 10 to the -1st power. Letter H. We would like it to be 6.923 between the first two digits times by 10 to what power? Well, we are going to move the decimal 1, 2, 3, 4 places. And since this was a really small number, we are going to get a small negative exponent. So you're counting how many places you move the decimal. If it is a big number, you get a big positive exponent. If it is a small number, like these 4 were all small numbers, you get a small negative exponent. Example 2. Now, we're going to do the opposite. We're going to write these numbers in scientific notation. So these are, well, they're not scientific notation. They're not even standard form. They're just numbers. But we want to write them in scientific notation. So let's see here. This might be like if somebody screwed up writing in scientific notation and we want to fix it, we can do that. So this decimal here is in the wrong place. To make this scientific notation, this decimal needs to be out here. I'll do it in blue, right there. That's where we want them to go. So if we can move this decimal 2 places over, then it would be in scientific notation. Okay, so this needs to be 8.342 times by 10. Now, they already moved the decimal 3 places, but look, it needs to go 2 more places that way. So my exponent needs to get 2 numbers bigger, would be to the 5th power. You can say that this is a big number. It's bigger than 1. This is a big number, so my exponent needs to get, it needs a big exponent, needs to get positive by 2 more places. Letter B. We have 72 times by 10 to the negative 5th. Okay, so first off, we know the decimal needs to go right here. And now they're using a dot for multiply. A lot of times you'll see it with the x for multiply. This is one of the few places you still see x for multiply is in scientific notation. But 7.2 times by 10 to what power? Well, I'm removing the decimal from here to here. So this number was a big number, so I need to use a bigger exponent. My exponent needs to get bigger by 1 place. Well, if it started out as negative 5, to make it bigger by 1 place value, what is one number bigger than negative 5? Hopefully you're thinking it's negative 4. Negative 4 is one number bigger than negative 5. Now, we can check this. If I type this into my calculator, and I type this into my calculator, it should give me the same thing. 7.2 times by 10 caret negative 5. That's standard form. The other one is 7. Whoa. I messed up the first one, didn't I? Because it's not 7.2, it's 72 times by 10 to the negative 5th. Alright, now this one is 7.2 times by 10 to the negative 4th. And we got the same thing. Now, if this becomes confusing to you, one of the things that you may be able to do is, one of the future examples down here is we're going to write them into standard form. And maybe what you could do is you could write this into standard form and then change it back into scientific notation. It's kind of an extra step in there, but if you're finding this confusing, then maybe that method would work for you. So let me show this once to change this into standard form and then back. So if this method is confusing for you, actually I don't think we're quite ready for that yet. Go ahead and try letters C and D. Use the previous examples if you need to. Oops. There we go. And when you're ready to continue, hit play. We'll go through it together. Okay, so this should be 5.245 times by 10, and since this number out front is a bigger number, it is bigger than 1, we know the exponent needs to get bigger by 1 place value. So this needs to get bigger by 1 place value. That looks like 107, not 10 to the 7th power. Make my exponent just a little bit smaller. There we go. All right, this is 932 times 10 to the negative 1st. We need this to go to 9.32 times by 10 to what power? Well, this is a big number. So our exponent has to get bigger by how many places? Decimal starts here. 1, 2 places. So my exponent has to get bigger by 2 places. So what is negative 1 plus 2? Negative 1 getting bigger by 2 places would take us to a positive 1. Okay? more of the same, but now in these examples, this number out front is too small. So look at this. This number is too small. I need the decimal on the other side. I need this decimal between the 3 and the 7, like this. So if my decimal needs to be here, then when I rewrite this in scientific notation, since this number is too small, my exponent is going to get smaller. These numbers were too big, exponent gets bigger. These numbers were too small, my exponent gets smaller. Okay? So my exponent needs to get smaller by how many places? How many places would we move this decimal? From here to here. Well, we're going to move it one place. So my exponent needs to get one place smaller. It's going to go down by 1. So it's going to be 10 to the third power. And if you wanted to double check it, we haven't checked on the calculator in a little while, just to make sure we understand and make sure that we've done everything properly and so that you believe me that I'm not lying to you. So if we have 0.372 times by 10 to the fourth power, that's what this number is in standard form. Now, in proper scientific notation, 3.72 times by 10 to the third power. Oh, I forgot my caret. We got the same number. So these have the same value. The bottom one here is in proper scientific notation, where the top is not. Okay, letter F. So I would love to have my decimal between the 4 and the 6 right there. So 4.6 times by 10 to what power? Well, I'm looking at it and I'm saying to myself, this number out front here is too small. So my exponent needs to get smaller by how much? By 1, 2, 3 decimal places. So right now it's at -8. It needs to get smaller by 3. It needs to go down 3 more, which is going to put it at -11. 4.6 times 10 to the -11th. Another way you might think about this is whoever was trying to change this into scientific notation, so the actual number, this number here in standard form, would be 0.1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so that's this number in standard form. Both of these numbers in standard form would look like this. So you could imagine some person, they were trying to change this into scientific notation, and they moved the decimal 8 places. And since this is a very small number, that's why they used a negative. So they went 8 places. They went 1, 2, 3, 4, 5, 6, 7, 8, and they stopped right here. That's this. But to make it proper scientific notation, they actually needed to move it a couple more places farther. They needed to go 3 more places. So it should be 3 more smaller. So a total distance from the beginning to the end would be 11 decimal places. Okay? So it's kind of another way to imagine what's going on here. If you could, please try letters G and H. Pause the video. When you're ready to continue, hit play, and we will go through it together. Alright, so letter G here. This we would like to be 3.9 times by 10 to what power? Well, this number is too small. We're going to make our exponent smaller. Smaller how many places? 1, 2 numbers smaller. So 2 numbers smaller than -2 would be -4. If you're at -2 and you get smaller by 2, you're at -4. Letter H. The decimal we would like out front would be 7.6 times by 10 to what power? Well, This number is too small. The exponent is going to get smaller by how much? By 1 place. So 5 minus 1 is 4. Okay, so these are just kind of numbers that were almost scientific notation, how to make them proper scientific notation. Next example here says, determine if the following numbers are written in scientific notation. So, the number we're looking at, is it scientific notation? If it's not, then write it in scientific notation. Okay. So just identifying, is this proper scientific notation or not? So first one, proper scientific notation? No. No, it's not. Because this number out front is not between 1 and 10. So to fix this, this would then be 3.4 times by 10 to what power? Well, since this number is too small, my exponent is going to get smaller by 1 place value. So it goes from an 8 down to a 7. Letter B. Is this proper scientific notation? Yeah. This number out front is between 1 and 10. This guy here is an an integer. I think we're all good. This is proper scientific notation. Yes. Okay. Here's 2 for you to try. So if you could, please try to take these numbers and turn them into scientific notation if they're not already. Pause the video, try them on your own. When you're ready to continue, hit play, and we will go through them together. Okay, so let's see what we have here. This is good. The first part here is good. So it should be 8.32. The problem is this guy here is not 10 to a power. So what power would that be? Well, you could always do some guessing and checking your calculator. You say, well, is it 10 to the second power? No. Is it 10 to the third power? Yes. 10 to the third power. Just some problem solving. Guessing and checking is a valid problem solving strategy. Don't forget that. If you're looking like, oh, I don't know what to do, well, try something. The calculator is a wonderful tool that you don't have to do this math in your head. It can evaluate something like this for you very quickly and very easily. Letter D. Okay, I can already see this is not scientific notation because this number out front here needs to be 4.2 times by 10 to a power. Now, since this number out front here is too small, I know my exponent is going to get smaller. By how many places? Well, the decimal needs to go 1 place to where I would like it to go. So the decimal is going to get smaller by 1. So 5 down by 1 is 4. So neither of these were in scientific notation. Okay, we got a couple more of the same. Is this scientific notation? No, it's not, for a couple reasons. First off, this is not a power of 10, and this is not between 1 and 10. So, fix. Negative 9.3. This might be your first time seeing a negative out front, and that is perfectly fine. You can have a negative out front. The decimal out front can be negative. Now we just got to find a power of 10. 10 to what power would make this work out? Well, if you don't know it, take a guess. 10 to the third power? No, that's too big. 10 to the second power? Aha. Oopsie. I just realized that I almost did the problem wrong. This right here is 10 to the second power. But I forgot. I moved my decimal. Look. I moved the decimal from here over to here. So I need to change my exponent. And since this number is too big, my exponent actually needs to get bigger. by one place value. So it's going to go from 10 to the second up to 10 to the third. Okay, so let me refresh and explain that problem a second time. So we very quickly found that this 100 is 10 to the second power. Now, in order to change this number into scientific notation, even if this was, say, negative 93 times by 10 to the second, we needed to make this number out front have the decimal in the proper place, which was between the 9 and the 3. So we had to move, oh man, whatever. We had to move that decimal there from here at the end, since it's a whole number, one place forward. And since the original number here was too big, our exponent had to get bigger by one place. All right, letter F. I see some big problems here. This is not even a power of 10. It's not 10, 100,000, 10,000, 100,000. It's 200. That's going to be a problem. And this is not even a decimal. So here's what I'm going to do. I'm going to take this in my calculator, and I'm just going to multiply it together. And then get me some number that I'm going to change into scientific notation, okay? So here I have 0.0048 times by 200. That gives me 0.96. Now I'm going to take that and I'm going to write that in scientific notation. Okay? So I know that I would like the decimal to be 9.6 times by 10 to some power. Well, what power? Well, how many places did you move the decimal? We moved the decimal one place, and since this number here is a small number, less than 1, I'm going to get a small exponent, negative 1. Some people also remember that when you move your decimal this way, you get a positive exponent. When you move your decimal this way, you get a negative exponent. If you do that, that's fine. So you move the decimal negative 1 places. Move the decimal positive 1 places. Something like that. Letters G and H. If you could, please go ahead and pause the video. Try these two problems on your own right now. When you're ready to continue, hit play, and we will go through them together. Letter G. Okay, let's see. So this is between 1 and 10, so that looks good. This is 10 to a power. That looks good. So yeah, this is actually scientific notation. Yay! We didn't have to do anything. All right, nice. Letter H. This number here, this number out front, is not between 1 and 10. So we need to change it. So it's going to become 8.23. Move the decimal over 1 place. Times by 10 to what power? Well, since this number here was too big, our exponent is going to get bigger. By how many places? Well, how many places would you move the decimal from where it started to where you want it to go? You move it 1 place over. So it goes from being to the first power, add 1 place. It's now 10 to the second power. Now, example 4. Now it asks us to write the numbers in standard form. So basically now what we're doing is the opposite of what we've been doing in all the other problems. We're going to take a number in scientific notation and write it in standard form. Okay, so, well, it is kind of the opposite. So first thing I'm going to do is I'm going to write down this number out front, but without the decimal. I lied. Well, if you write the decimal, just write it lightly. Just a little ghost mode in there. Now, we need to move the decimal 2 places here. 2 places which way? Well, this number out front here, or I'm sorry, this exponent is a positive exponent, which means my number in standard form needs to be a big number. Remember, big numbers get the positive exponents. The small numbers get the negative exponents. Since this is a big positive exponent, this needs to be a big number. So which way would you move this decimal this way or this way to make this a bigger number? The answer is you would move it that way. Make this number, if you move the decimal 2 places to the right, this number becomes 256. That is this number in standard form. So you write down the decimal piece, you move the decimal the number of places they ask you to. If it's a positive exponent, you make your number bigger. If this was a negative exponent, you'd make your number smaller by moving the decimal the other way. Letter B. So my number out front is just 3, and I need to move my decimal 8 places bigger. So my decimal starts right here. This is a whole number, the whole number 3. So it's 3.0. And I need to move my decimal 8 places. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. And what's going to go with all those empty spaces? Well, zeros, of course. Now, this is pretty ugly with our little swooshy guys, and we don't have commas in there yet. So usually what I'll do is either with pencil, I'll erase my swooshy guys, or if you have the space, just rewrite it, making it pretty. So I'm going to rewrite it. Now, I paused a second there just to see where my commas would go, because I know a comma would go right here, because you go from the end. 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma, like that. So I was leaving spaces in here for my commas to fit. So this is the number 300 million. And that's actually pretty easy to put in the calculator. 3 times by 10 caret 8. Now the calculator doesn't show commas, but 1, 2, 3, comma, 1, 2, 3, comma, and then the 300 out front. Okay, so that's standard form. Big number, big exponents give you big numbers. Go ahead, pause the video. Please try these two on your own right now. When you are ready to continue, hit play, and we will go through them together. Alright, so I can even do it right here. Instead of writing down, again, I can kind of move my decimal in the problem itself. So this is 10 to the 4th power. So since this is a big number, I'm going to make my number out front bigger. So I'm going to move my decimal 4 places this way. 1, 2, 3, 4, which is going to give me 3,746.3.8, because now that's where the decimal goes. I moved the decimal 4 places, so now that's where his home is, between the 3 and the 8. And throw a comma in there. So from the decimal, 1, 2, 3, comma. That's the number 37,463.8. Letter D. This says I need to move my decimal 3 places from here. And since this is a big number, our decimal is going to go to the right to make this number bigger, because right now it's 8.3. If I move it 1 place, now it's 83, 837, 8,337, 837, actually no, 8,370. And there's my decimal at the end, 1, 2, 3, comma, 8,370. Okay, so all of these we changed from from scientific notation into standard form. What if the number out front, what if the decimal up top is a negative? Well, we're going to do the same process, except the difference here is, since this is a small exponent, then our number out front needs to get smaller by 6 decimal places. So from here, 1, 2, 3, 4, 5, 6 decimal places smaller. And then all these empty spaces we fill with zeros. So I need this number to be 0. I'm trying to keep track of everything here. 1, 2, 3, 4, 5 zeros, 6323. Just making sure everything was lined up properly. Yep. And since we are after the decimal, we do not put commas. There's no commas after the decimal point. So then this would actually be done. Okay, letter F. I'll move him over as well because I know I'll be moving my decimal 9 places smaller this way, and I need some space. All right, so here's my decimal. 9 places. Here we go. Small, smaller. 1, 2, 3, 4, 5, 6, 7, 8, 9, which gives me 1, 2, 3, 4, 5, 6, 7, 8 zeros. Okay, so I'm going to have 8 zeros before I get to the 832. 1, 2, 3, 4, 5, 6, 7, 8 zeros. And there we go. We have our number now in scientific notation. I'm sorry, in standard form. Here are, I believe, probably the last 2 of this type of problem. So if you could please pause the video, try letters G and H. When you are ready to continue, hit play, and we will go through it together. Okay, letter G. Decimal starts here. We need to move it 4 places smaller. So we're going to go 1, 2, 3, 4, which means I'm going to have 3 zeros in front. So 0.0009. And if you like that extra 0, 0.0009, you can do that. And that's done. Okay. I need to move my decimal 2 places smaller. So this is going to become from here 1, 2, 0.0, because I only get 1 0 up front this time, 0.0733. Okay, so we have standard form big numbers, we have standard form small numbers. Example 5 says, for each problem, use greater or less than, greater than, or equal to fill in the blanks to determine which number has the greater value. All right, so I want to say which of these is bigger, this guy here or this guy here. Now, I'll be honest, I don't even have to take out my calculator for this one because I know since this has 10 to the -9th power, I'd be moving my decimal 9 places that way. So this is going to be point like 0.0000000, a whole bunch of 0.832. In fact, I don't probably even have the right number of zeros. 1, 2, 3, 4, 5, 6, 7, 8. There we go. So this number versus that number. It's clearly this is the bigger number. Remember, it always opens towards the bigger number. Like you got old Pac-Man, he likes to eat the big thing, or the alligator, however your elementary teacher taught you. Okay, so it opens towards the bigger number, like it's going to eat the bigger one. So this one is bigger. Letter B. Okay, now that one's not quite as easy. I can't just look at it right away and tell. So here's what I'm going to do. I'm going to change them both into... do I want standard form or do I want scientific notation? I can do either. Let's do scientific notation. So this number here would be 3.2 times by 10 to what power? Well, from here you'd go 1, 2, 3, 4, 5, 6, 7. Ah. Now, oops. This number here, 7. This number here is smaller than this number here. And here's how I can tell actually pretty easily. I can tell because this exponent is smaller than this exponent. Really, that's the only thing I have to look at. If the exponents are different, the one with the smaller exponent is the smaller number. So I know that this number over here is bigger. I could have done that up here too. If I would have changed this 3.45 into scientific notation, it'd be 3.45 times 10 to the 0th power, which is technically true. Yes, so which exponent is bigger, -9 or 0? Well, 0 is bigger, so that's the bigger number. And if you don't like changing the scientific notation, there's nothing here that says you have to do that. You could change them both into standard form. We could have changed and moved this guy, moved the decimal 8 places this way, making it 3 from here. 1, 2, 3, 4, 5, 6, 7, 8 places, comma here, and if I erase this junk, you say we got 32 million or 300 million. Still, he is bigger. Multiple ways to do the same problem. Find the way that you like. Letter C. Okay, go ahead and copy it down and figure out which of these numbers is bigger. Okay, so let's see here. If you didn't get a chance to do this, go ahead and pause the video and do it, but I'm going to be moving on. So, again, I can go either way. I can change this guy into standard form. I can change this guy into scientific notation. I'm going to go with scientific notation. So, this should be 4.5 times by 10 to a power. Now, since this is a small number, I'm going to have a negative exponent. And I need to move the decimal 1, 2, 3, 4 places. So actually, these two are equal to each other. This is the same thing as that. When I wrote this number in scientific notation, I got the same answer as the other side. So these are actually equal. Example 6 says, how can you tell by looking at a number in scientific notation if the number represents a very big or a very small number? Well, you can tell by looking at the exponent. So, if I'm looking at a big number, then my exponent, say the number out front is 3.45, whatever, times by 10 to the, if I have a big number, the exponent out here would be a positive something. If I'm looking at a very small number, then I'll use that same 3.45, then the number above the 10 will be a negative, say -2. So it really depends on your exponent. Big numbers have positive exponent. Small numbers have negative exponents. Letter B. Mr. Einstein's class is studying how light moves. The speed of light moves approximately 671 million miles per hour. Express this number in scientific notation. Okay, pretty straightforward problem. So 671, 000, 000. All right, so if I want that in scientific notation, I know I need the decimal right there between the 6 and the 7. So 6.71 times by 10 to what power? Well, since this is a whole number, the decimal started at the end. So you'd move the decimal 1, 2, 3, 4, 5, 6, 7, 8 places. And there we have it. Letter C. In the year 2000, Americans consumed an average of 47.2 pounds of potatoes and 5.936 times 10 to the second power pounds of dairy products per person. Did Americans consume more potatoes or more dairy products? You do not have to write out the whole problem if you do not want to, but you do have to do the problem. So if you could please pause the video, try the problem on your own. When you're ready to continue, hit play, and we will go through it together. All right, so the question is really coming down to, is 47.2 bigger or is 5.936 times 10 to the second power bigger? Which of these is the bigger number? And you can do it either changing this guy into standard form, this guy into scientific notation. I'm going to go to standard form this time because I haven't done that yet. So if I change this into standard form, so I'm going to move my decimal 2 places, and since this is a big positive, my number out front is going to get bigger. 2 places this way. Changes it from 5.93 to 593.6. So what number is bigger? Is the 47 pounds of potatoes bigger, or the 593 pounds of dairy products bigger? The answer is, yeah, clearly the dairy is bigger. So the year 2000, the average person ate almost 600 pounds of dairy products. That's cheese and milk and ice cream and stuff. Oops. Last problem. Question says, which set of numbers below is written from the smallest to the largest? Okay. So I'm looking at this, and I see a couple problems right off the bat. I can see that letters C and D are wrong. And here's how I can tell. Remember how it was a few problems back when I was comparing some numbers. It was on this page. When I was comparing numbers, I was looking at which exponent was bigger, and the bigger the exponent, the bigger the number. Well, right here, if I'm trying to go from the smallest to the largest, look at these exponents. 6, 2, -5. Those are not in order. If this was even closer order, like if the -5 was first and then 2 and then 6, then I would say that's probably right. But here, those aren't even close to the right orders. And same thing here. Look, 6 is not smaller than 2, and that's not smaller than -5. So these exponents are throwing this off. For them to be in the proper order, the exponents would have to be in the proper order as well. So it's not C and it's not D. So now we're stuck between these two. They both agree that that is the biggest. They both agree that that is the next biggest. So it really comes down to here. Which of these numbers is bigger or smaller? Well, let's see. So I'm going to change this guy. Actually, I'm going to change this guy into scientific notation. That way they're all scientific notation. So if I take this, and so it's going to be 4.0 times by 10 to what power? 1, 2, 3. And because this is a small number, it's going to be a negative. All right, so, and this would be the same thing. It's 4 times by 10 to the -3rd power. So now we got to figure out which of these is in the proper order. Is it -3, -5, 2, 6, or is it -5, -3, 2, 6? The answer is this one. That's the correct order. The smaller the decimal, the smaller the exponent, the smaller the number. So this number is smaller because the exponent is smaller. You'd have to move 5 decimal places over. This guy, you only have to move 3 decimal places over. So he's not quite as small. Here, to change into standard form, you'd move 2 decimal places, makes him 420. This guy, you'd have to move the decimal 6 places, which makes him like 9 million. Okay, so this letter B is the correct order from smallest to largest. And you can use your exponents when your numbers are in scientific notation to help guide you to that answer. Last, or summary, I should say. So the summary for this first lesson says, how do you know whether to move the decimal to the left or to the right when changing a number into scientific notation? So just think of an example, into scientific notation, so no decimals yet, 3876.24. So in that example, how would you know whether you move the decimal to the left or to the right when you're changing that into scientific notation? Okay, so you can answer the question on your own. This has been lesson 2.1. Thank you for watching.